Hello and welcome to AI Curious. My name is Jeff Wilser. I am a journalist, I am a human, and I am curious about AI. So one thing that makes AI so mysterious is that it's so abstract. People use buzzwords like neural networks and large language models and machine learning, and we all kind of nod like we know what that means.
But really it sounds like a AI magic wand, more or less.
So to bring some clarity and to demystify, I thought it might be helpful to instead get very concrete with one hyper-specific example of AI in action. And because I'm a huge tennis nerd, the example we're going to use involves tennis. If you've ever watched tennis in the past, like 10 years, you've seen something called a Hawkeye, where when we're not sure if the ball is in or out, the computer zooms in really close and you see exactly where the ball bounced. It's a system that's very expensive and it uses tons and tons of cameras.
So it's generally only used for the Grand Slams like Wimbledon and the US Opens and the like.
Now, I play a lot of tennis myself. To clarify, I suck. I'm really not very good. And it's kind of hilarious as an aside. I play all the time. People assume, oh, Jeff, you must be good. No, I just like playing and I'm very mediocre.
And about a year ago on Instagram, I saw an ad for something called SwingVision AI.
So this is an app that promises to turn your iPhone into a system that uses its camera to track every shot, record your match, and will even let you see in real time if the ball is in or out right there on your wrist on your Apple Watch. This seemed to me, frankly, kind of ridiculous. I didn't buy it. Then I played with a friend who actually tried it. He showed me it in action and it worked. I was kind of surprised. So I got it for myself. So it's kind of wild how good this app is. You basically hang your phone somewhere that can see the whole court, usually on the fence behind you. And then later, when you're done, you see all kinds of stats like the speed of your serves, the percent of your backhands in or out, and on and on. This is one reason why SwingVision is an editor's choice in the App Store, why it won Apple's prestigious design award alongside apps like Headspace and Duolingo, and why they now have 15,000 paying subscribers, including over 100 Division I college tennis teams. All of this, of course, is powered by AI. But how? How does it work? To get into the AI-ness of it all, I invited onto the pod and spoke with the CEO of SwingVision, Swupnil Sahai. And I don't think, frankly, you need to care about tennis to appreciate this conversation. Because really, we're using tennis as one massive metaphor. Through the prism of tennis and creating an app for tennis, we get into some of the tricky details of how AI models work, how they speed things up, and what are their strengths and drawbacks. For example, there's this weird paradox of how AI is really good at calling in or out on the close calls, but it's kind of lousy at calling in or out when it's obvious. Like if I, in my shots, when I smack the ball 40 feet out of bounds and over a fence, the AI might not get that right. And so we kind of cover why that is and what it could mean for AI at large. And as an added bonus, Swupnil started as an engineer at Tesla, where he worked directly with Elon Musk on the AI that powered self-driving cars. So he shares some kind of fun stories from his time at Tesla, what he learned, what Elon taught him, and whatever your thoughts on Musk at the moment, he does know a thing or two about AI and self-driving cars. And on an aspirational note, I think anyone working on building an AI company, and there are many of you out there, can learn from Swupnil's story. So please enjoy my conversation with Swupnil Sahai, founder and CEO of SwingVision AI. Swupnil, welcome to the pod. Great to have you.
Yeah, thanks so much for having me, Jeff. Super excited.
So tell us, what is SwingVision AI and how does it improve our tennis games?
Yeah, well, it's essentially just an app on your iPhone that you can use to record your game. But then the cool part about it is that in addition to that, the app will also automatically track all of your stats. It'll generate highlights of your best points, and you could even challenge line calls. So you can actually settle disputes on the court with this technology that's more accurate than the human eye. So it really elevates kind of all aspects of the experience, whether it's actually playing the game, sharing it afterwards, reviewing your performance and trying to get better. Really, kind of all aspects of playing tennis.
So I have to admit, I think I first heard about this through an Instagram ad because Instagram knows I am tennis obsessed and it served this up to me. And at first, I assumed, frankly, it was total BS. There's no freaking way that my little phone is going to accurately capture what's happening on the courts. The idea of real time line calls to me seem like absolute fantasy, science fiction, just
Yeah.
hogwash. I'm so curious, what sparked this idea? It's a fairly outlandish thought that you could use artificial intelligence and marry that to your iPhone and to your Apple Watch to serve as effectively a chair umpire for amateur tennis. When did you have this idea, and what gave you the confidence that you could somehow pull this off?
Yeah, it is kind of crazy. Every time I introduce it, it just sounds ridiculous. But and that's definitely like a lot of the comments we get on our ads are like, "There's no way this is real. This is bullshit. Like, how could it be possible?" But basically, yeah, I'm a lifelong tennis player. That's been my main sport, and I saw my running and cycling friends had Strava and these amazing apps to track their game. And so, actually, originally the inspiration was just like, "Hey, I want some stats on my game. I want to know like how's my serve doing." Was my backhand the issue the other day when I lost the match? Like, what was the problem? And every tennis player has this issue, and we wanted just a way to automatically track that. How could we do that? And kind of just studying the problem in the space. There were some solutions for this problem, but they're all super expensive. You have to install like 10 cameras on the court to triangulate the position of the ball, which then lets you track all these stats automatically. And then obviously the other alternative is like you have somebody sitting on the sidelines, like recording everything, which is obviously, not scalable. So that was basically sort of like the state of the world before SwingVision. And it seemed like we'd have to really make that a lot more affordable to give that to everybody. And really, that really comes down to having fewer cameras. And so I was like, can we do this with one camera? Which, again, as you said, sounds completely ludicrous. But I think I was really inspired working at Tesla. So I was there working on the autopilot team, using the cameras to track the objects. And I was specifically working on like tracking these objects in 3D with a single camera because Tesla famously doesn't use LiDAR or these other sensors.
Can you
And
unpack?
so,
Sorry. Can you unpack that a bit of what lidar
sure.
is and how that's different from a kind of the approach they went with?
Yeah, yeah. So, most of the other self-driving companies like Waymo, they're using these really expensive sensors that can cost like upwards of $50,000. And what they do is they shoot out these like laser beams or light beams, and they're like a depth-based sensor. So, like, determines how long it takes the light to go hit that object and come back, and then
Like
that's how you know like
like
how
a
far it is.
bat with sonar. If my seventh grade science is right on this.
Yeah, it's like a 21st century sonar. So, it's going in all directions, up and down, and it's very, very precise, like accurate to the millimeter. And it's really the best way to get the most accurate information of how far away everything is around you, right? Because when you're driving on the road, you want to make sure, like, how far is that curb? How far is that pedestrian? How far is that next adjacent vehicle, right? And so that's what a lot of the companies are using because it gives you the highest level of precision. But it's very difficult to put that in a consumer product like a Tesla, where individuals are actually buying it rather than like a rideshare service.
Mm.
And so you need something that's going to be more cost effective. Again, very similar to SwingVision. And Elon's approach was basically that, like, well, humans don't have these fancy sonar, sensors in their mind. All they have is their eyes and their ears. So like that's all you should really need is just something that's vision based, a camera. And so that's kind of the approach they took was, okay, instead of getting this really expensive sensor, let's get a camera, which is really not that expensive at this point. It's very cheap to get cameras. And then we built this really incredible software that takes the pixels that are coming into the camera, being captured by the camera, and then, translate that into like a map of what's happening around you in the world in 3D. And so, theoretically, it's not going to be as accurate as these like fancy sensors, but the idea is humans also aren't that accurate, and they can still drive okay. Obviously, they're not great because all kinds of accidents happen, but we just got to do better than humans, and we'll build a much safer car on the road. And so that was basically the experience that we built at Tesla. And it's a very challenging problem. It's much harder to do it without those sensors. There's a lot of innovation that needs to happen on the side to process those pixels accurately. And traditionally, determining how far away an object is usually requires at least two cameras to like triangulate precisely where it is, just because of the geometry and the math of it all. And so, the project I worked on was sort of figuring out how we can do that with a single camera using neural networks, which is sort of like the latest version of AI that's become very popular now, specifically for images and now also text. How can we use AI instead of having this complex hardware? Let's build this complex software, but using very rudimentary hardware, actually. And so I got really experienced in that problem. And then when I was thinking about the tennis problem, I literally thought in my mind, like, what would Elon do? And he would say, like, just use your iPhone. Like, let's keep it simple. Let's make it really affordable for the consumer. Let's not try to make this too complex. And yes, it's going to make the engineering like 10 times harder. But ultimately, if you can nail it, it's going to be the best product experience. It's going to be the most affordable. It's going to scale the best. And so I kind of just went with sort of that intuition, first principles from what I thought the way he would have approached this. And that's why we took this approach. And so obviously it's sounds crazy and it's incredibly difficult what we did. And there's still, even today, 4 years later, no other product that's been able to do this with just one camera. So I think we have a really nice lead there. But yeah, it was definitely kind of a crazy idea. But I think that was what basically gave me the confidence, was sort of working at Tesla and working with him.
Amazing. And to clarify, was Elon personally involved in the development of that single camera approach? And did you have discussions with him about doing it this way versus that way?
Yes, 100%. We had weekly meetings with Elon, with the Autopilot team. Actually, it was really funny. When I was there at the Palo Alto office, the entire Autopilot team was like right in front of Elon's desk, basically. So like he had his eyes on us more than like anybody else. So he was sort of like watching our every move, but obviously he's busy.
No pressure.
No pressure. Yeah. We always called it like we're in the eye of Sauron. So that's kind of how it felt. And so, yeah, we'd have like weekly meetings with him. I presented to him constantly. We had many discussions actually about this whole camera problem, because there was one particular project where we were trying to figure out like how to make the car automatically change lanes for the first time. Because up until that point, you had to sort of manually like hit the indicator when you felt it was safe, and then the car would go. But we were trying to do automatic lane change. So I was working on that problem, which was like tracking the cars using the rear cameras. And that was actually the first time we were working on cameras that didn't have a radar sensor as like a backup, because at that time the front of the car had a radar. So at least you had sort of cameras and like some radar working together. But on the back, you just have cameras, no radar. So for the first time, you're using just vision to track these objects. And so I had this discussion with Elon directly, and I said, I think it'd be really helpful if we could get some radar sensors. Like, they're not that expensive, actually, if you think about it. I remember the number. Let's say it's like around $10, $20 a sensor or something, which, sounds pretty cheap for like a $30,000, $40,000 car. But his response was basically, well, that makes a lot of sense, but we have so many teams working on this car. Every engineer wants more things on the car, and so if I keep saying yes to everybody, it's going to make the car like $10,000 more expensive at some point. So you have to kind of be strict and put your foot down and say no. We're going to try to solve this with software and with the resources we have, and it's going to take longer potentially. But again, if we can solve it, then we don't need to add that extra hardware. It keeps the car more affordable. And so I thought that was such an interesting insight. And me as an engineer working on that sole problem, I wasn't thinking at that big of a scope at that macro level. But obviously, as a CEO, he's looking at everything, and so he was able to explain that to me. And I still kind of resisted, but I was like, okay, fine. You're Elon. I guess I'll trust you. And then we actually ended up solving the problem. So it was also amazing from that standpoint that not only was his rationale quite good, but he also was able to almost make us like do more than we thought was possible of ourselves, which I thought was really inspiring. Like, that was really inspiring to have that moment. I've always read stories of like Steve Jobs doing that and putting like crazy deadlines and ambitions and like making his employees do things that they don't even think is possible for themselves. So I think Yeah, that was just a great experience overall. And that's just, I brought a lot of that mindset, I think, to SwingVision as well.
One thing I'm still fuzzy on is for many projects like this is the specifics of how AI is
Yeah.
involved. I understand at an abstract level, at a high level, yes, it's a secret sauce that makes this kind of data processing happen, right? I get that.
Yeah.
Yes, it lets numbers be crunched very quickly. I get that there's pattern recognition involved, but I'm still a little fuzzy on the mechanics without getting 5 miles deep in the weeds,
Yeah.
but going a bit in the weeds. Can you, for a layperson, help explain how AI and neural networks are used?
Yeah, for sure. So, I mean, at least at SwingVision, for us, it all comes down to the ball tracking. And then if we can track the ball accurately, then we can do all these other really cool things on top. We can, do line calls. We can give you stats. We can look at your stats over time and pinpoint like what's wrong and what's really jumping out in today's match versus previous ones. But that's really kind of the core, I think, for all the experiences that we're able to provide to our customers. And then in terms of the ball tracking, that's really where the chunk of the AI comes in, especially the neural network part of things. There's other interesting AI things you can do on top later with that data, but I think generating the data is really where the AI comes in for us. And so traditionally, if you're trying to solve this problem, which at kind of like a highest level, the problem is you have a video and tell me where the ball is in 3D. Like that's basically what you're trying to do here. Traditional way to do that would be before like neural networks became popular.
So, do you mind? Sorry, I jump in. Can you actually, at the risk of being extremely ignorant here, to make sure we are grounded here, can you describe briefly what neural network means exactly?
Yeah, I mean, I guess it helps to understand a little bit of the context of like how these problems were solved before. So before you'd say like, I'm looking for specific features in this image that are going to be relevant to determining where the ball is in 3D. And so those features might be like the corners of the court, the lines of the court, the ball itself, a circular shaped object. And so traditionally you had to have like computer vision experts or domain experts come in and say, these are specific features that this like statistical algorithm needs to look for. And if it finds those features, that's indication like that's where the ball is, that's where the court is. And therefore we can figure out some based on geometry where this ball must be. So that was sort of the old school way of doing things. And then the big innovation with neural networks is it's a new type of, I guess, modeling approach where these features are learned automatically. So instead of saying this is explicitly like a ball, this is explicitly the corners of the court, now what's happening is you're just saying, here's a video, and here the answer is that the ball was out. And here's another video, and the ball was in. And then let's just do this a million times. And then you, algorithm, go figure out what features are important. Maybe the ball is important. Maybe it's actually the shadow of the ball that's important. Maybe it's some other feature that I couldn't even think of as a human that's important. And so that's been the brilliance of neural networks, is that they will figure out what features in your image or your video are actually correlated and important with respect to the task you're trying to make this algorithm, estimate, which in this case is like in or out accuracy, let's say. And so if you give it enough examples, it will start to pick up like what features, visual features are actually correlated with, the task I'm trying to do. And if it's like self-driving cars, your task might be like figure out where all the cars are around me, like my surrounding objects. Those features that are relevant might be like the wheel of the car or like the headlights or like the window, but I don't have to explicitly tell it those things. I just need to tell it that like, here's a bunch of images. Here's where the cars are. Some human labeled that. Now you go learn and figure out what features were actually important. And so that's really the big innovation with neural networks, is like a lot of that manual work that needed to be done before, kind of guesswork, is gone now. And it's become more of a problem of just getting lots of data and making sure it's labeled really accurately. And then the algorithm will kind of figure out what features are important. And like you actually, as a user, don't even, or even a developer, don't really even care what features it comes up with, because that's not really what's relevant. All that matters is like, is it getting the right answer?
Got it. So thank you for that primer. So when you left Tesla, you had this idea that neural networks can be leveraged to summon this magical outcome of these stats, these insights, the tracking, all from one camera. But it took you, year, 2 years to kind of
Correct.
make it happen. What was the biggest challenge you had to overcome? Did you spend thousands of hours just pumping in old Jimmy Connors videos? Were you playing with new people on courts? Was it archival stuff? How'd you develop this model?
Yeah, I think that was the biggest challenge was just scaling up that data set. With this type of problem, as I was mentioning, really it just comes down to like how big is your data set. With these modern neural networks, the more data you have, the more accurate, the better the predictions are going to be. And that's what OpenAI has had to do that work, and they've scraped a bunch of data from everywhere. And for us, we couldn't do that. We had to follow more of like Tesla's approach, which was like, let's try to get something out in the hands of customers. Like we'll go out in the world and record all around the world, and then we'll start to get a bunch of data coming in from our customers, and then that's how we can like train this AI engine to get more and more accurate. And so the biggest thing was just shipping something that just like barely works as soon as it works. And for that first summer, we did do what you were alluding to. We did scrape YouTube for like old matches. We didn't really go back to Jimmy Connors because they didn't even record at 30 FPS, let alone 60 FPS back in the day. But we did find we have some Federer and Djokovic matches in there that we pulled from YouTube. Not sure if it was legal, but we pulled it anyway. And then we also pulled all kinds of user videos because there was already some culture in some tennis communities of like recording your match with a tripod and like uploading it to YouTube. But obviously they would manually edit it and remove all the non-playing time, which now obviously you don't have to do with SwingVision. And so that was really helpful too. So there's just actually a lot of YouTube footage that we pulled. And then we did go out around the Bay Area because that's where our company was based at the time. And so we would go out and just record random matches. We'd go and record like at academies with like really top players who were just practicing with their coach. We recorded college players like at Stanford and Berkeley. So we got a lot of footage from various people around the Bay Area, and then sort of bootstrapped it from there. Got an initial model. It was decent, not great, but it was enough to just kind of ship something out in the market. And then all of a sudden we started getting people all around the world using it, every single country, every different lighting condition, court surface, whatever you can think of. I mean, at this point we have the most diverse like tennis footage in the world, and that really helps kind of beef up the algorithm and find these weird edge cases. There's a weird shadow on the court at like just the right spot that's making it difficult. We have an example of that, thankfully, right? So that collection of data was really important. And then we still train it today. Even the original algorithms, we still kind of, every month or so, we're kind of ingesting more data, more hard examples where people are finding mistakes. So that can just get better and better. And it's going to be sort of like a never-ending problem to some extent. But, once we can get to a high enough threshold of accuracy, you could start using this in like competitions and things like that. So it's very exciting.
What was it like in the early days before you had this kind of small ocean of data, when you might have had only a few matches or YouTube videos? My guess is, was the 80-20 rule in effect here, where actually with only, let's go extreme, let's say it only literally recorded one match, all it knew.
Yeah.
And then it's able to actually, that does a decent job saying that's in or out, but you wouldn't trust it with a $5 bet.
Yeah. I mean, I think that initial summer we were recording probably like 2 hours of footage every week for, let's say, maybe 2 or 3 months. So that was like the initial footage we started with, plus whatever we scraped from YouTube, which was maybe, let's say, another equivalent amount of data to that. And then I think with that, we got to probably around high 70s in accuracy, which is pretty bad. But we just launched it anyway. We launched it in November of that year, 2019. And we said, let's just get it out. Like, it's going to be so embarrassingly bad, but like, there'll at least be some early adopters who will understand.
Great tagline, man. Great slogan. Embarrassingly bad.
Yeah. I mean, that's what I think, like Paul Graham or someone at Y Combinator said that, right? Like if you're not embarrassed with your first product, you ship too late. So we definitely took that to heart. And we're like, we are extremely embarrassed with this. It's time to ship.
Love it.
So we got it out there, and lo and behold, people were pretty pissed because they're like, "What? This is not that good." But there was a small set of folks, and we love them and thank them for sticking with us this whole time. And they continue to use it. They're like, "It's okay. I'm still going to record. I'm going to give you more data. I believe in what you guys are doing. No one else is doing this. I want to help you." And that's all we were banking on, was like, if we can just get like 100 people who like this, and they're going to go and record, and like, eventually you'll get better, and then we'll get to 200, and then from there, as it gets more accurate, more and more people, it will kind of cross their personal threshold of what they think is accurate. And that's just kind of took it from there. But I mean, it really was not accurate at all. Obviously, we wanted to be better than like a coin toss. I don't want it to be like 50%, but it was like high 70s, low 80s, kind of around the time we launched it, just with that data. And then from there, as you said, it's kind of diminishing returns. So you have to get like a lot more to get to 90. Now we're at like almost 95% in out accuracy for really close calls, like within 10 centimeters of a line. So like which, to give you a reference, for a call that close, human accuracy is about 90%. So we've actually surpassed human accuracy for like really, really close calls. So, and it's taken like 4 years to get there. So
what has AI been surprisingly good at? And then what has AI been surprisingly bad at?
So yeah, I mean, those close calls is really the one where I think you see the biggest magic. I'll often play a match with a friend, and it's just a friendly match, but we'll just challenge line calls for fun because sometimes the ball just goes so fast, like we have no idea, and I'll just be like, I don't know, I think that was out, but maybe you should challenge it. And so we'll challenge it, and it's like so clearly in or so clearly out, and the software gets it right. And I think that's just so cool to see that like we had no clue. The ball went so fast, like our stupid human eyes couldn't even see it. But this thing, like my little phone, is able to see it better than me. So I think that's been so wonderful to see that how often that happens. And then it's just surprising how good it is, even on like kind of both sides of the court. And again, it's because it's recording at 60 frames per second, and like the phone has these amazing chips that Apple's been making, the neural engine, and all that stuff. But then you'll have like simple calls where if you look at the video and the heat map, it's like totally wrong. A lot of times it'll happen where it's just like kind of edge cases, like maybe somebody just smacks the ball really hard and it doesn't even bounce, it like lands off screen. Like it's so clearly out, it's like off screen.
I'm okay. I'm curious in this in a couple levels. On just a fun joking around tennis level, I'm curious of why the calls that are easy to a naked eye, the AI struggles with. That's kind of goofy. But on a deeper level, I'm wondering what that might say about AI and the limitations and further challenges that have to be overcome. Why it can be extraordinarily powerful in these complicated, close calls, but it freaking misses the boat on the obvious stuff. Like, what does that say? Is there any larger point about the power of our basic meat bag, human eyes and brains, that we can see some obvious things AI can't? And how does that pose a challenge that AI data scientists and researchers have to overcome in the future? But let's start with tennis first. So why is why does it struggle with those obvious things? That seems wild to me.
Yeah, that's a really deep question, and it's kind of comes down to just the modern structure of AI that we're using. So these neural networks, they're kind of only as good as the data set that you give them. And so for these edge cases, like I mentioned, where someone just like hits a home run and it goes out of the fence, someone's playing the wrong sport, that kind of case, like we just don't have that many examples of that because like you're just not gonna, that doesn't happen that often, right? And so when something like that happens, the model doesn't know what to do. It's very low representation in the data set. It's much better at examples that it's seen a lot of that look very similar, And so when it goes close to the line, we've given it specifically lots of examples of that because that's the problem we've been trying to solve. And so, we have lots of examples of like really high level players specifically trying to hit close to lines. And so it's quite good at that now. It just has like thousands of examples it can draw on. So it's basically doing what you were saying earlier, which is like pattern matching, right? So It's basically saying, let's go look at all this data set we were trained on. What's the closest thing pattern wise? And like, let's give the result of that. That's basically what these models are doing. That's what OpenAI is doing. That's what pretty much all these AI models are doing. And so, with that, sometimes it'll be able to go beyond the scope of what is in the data, but it's not like a generalized intelligence like humans, right? And so humans are understanding something more fundamental about this game. They're understanding like the ball needs to go on this court, and anything outside of that is out. And it has that fundamental understanding. The model isn't that intelligent to have that generalized understanding. And that's maybe sort of the con of what I was mentioning earlier, where we didn't explicitly program it to know that like it's the core it should be paying attention to, right? So there's certain things there where there's like limitations, I guess, in that sense. But those are problems that can be solved, usually with either more data or like heuristics. In this case, like we know the ball is off screen typically for these scenarios. So even though the core model might not be getting the right prediction, we can use these other things that we know about the situation, about what's happening, the state of the world, to sort of like override the model by the human in a sense, and write some human code that would like override those situations. So there's kind of ways around it, But I think the big takeaway is just this is not generalized intelligence, and it's been programmed to do a very specific task, and ultimately it is quite limited to the data that you are collecting. There's, I think you see some really cool examples with OpenAI and ChatGPT and all that, right? But I mean, think about it; it's trained on like so much data around the world. I mean, think about how much literature or text you've read in your life, right? When you see something that looks novel, like how novel really is it? I mean, there's just so much text it's mined on. It might be based on some esoteric thing that someone actually said on Twitter one day, and like no one else has seen it. And so you're seeing it for the first time, and so you're thinking, "Oh my god, this is brilliant. This is so cool and original." But like it's not really that original. It's just kind of stitching together things that have been done before. And so, that's I think that's kind of the big takeaway. But I mean, at the end of the day, like it still can be very useful. And even some of those really cool generative AI applications, because they're combining things together, they do end up creating something that's truly novel. And I think that's very exciting, where AI is going to go there. But like for our example, it's a very specific problem where it's like I need to know whether it's in or out. There is a definitive truth. There's like an objective truth, I
Right.
guess, in our problem, and so it's like slightly different. And so for us, it's probably more gonna have to be just like a data problem. And
One reason why I was excited to chat with you is that this to me is a great example of AI being used in a surprising way that's kind of under the hood. I mean, yes, I know AI is in the
Mhm.
product's name, but it's not like a generative AI. It's not like it's going to
Yeah,
create a song or it's going
right.
to create a photograph. It's just powering something else that's cool.
Hmm.
And
Hmm.
my guess is there are many kind of sneaky applications like this out there that are happening or being built right now
Mm.
that folks
Interesting.
aren't really thinking about. What are some other use cases like this of AI neural networks being used as a means to a pretty cool end that people aren't really thinking about or talking about, but kind of excite and inspire you?
Yeah, that's really interesting. I guess there haven't been like that many yet. So most of the news has been all around kind of like generative AI, and I mean that's definitely very exciting. I think like anything that can sort of just process like high resolution data for you and generate some interesting insights out of it are probably going to be the most exciting applications. I mean, I think one I saw and I've used it a couple times is MyFitnessPal, and it's also like another, I guess, camera-based application. But historically with MyFitnessPal, you have to sort of like manually log everything, like how many calories this has, whatever. But they have this new feature. Yeah, they have this new feature now where I think you can like take a picture of your food and it'll sort of try to guess like what's in there and like count the calories for you automatically, which is like just making the experience so much better. And it's like you're not directly really interacting with the AI, like you said, but it's just powering like a much better experience. It's a much more convenient experience. It may not be as accurate as manually doing it, but it's accurate enough to kind of get you through your day and like get what you're trying to get out of that product, right? Which is like just tracking your calories at like kind of a bit high level. Um, and so I think like applications like that are really kind of cool. And then another one I saw, I forgot the name, but I think it's a company that just sort of like it sounds a little sketchy, but it records like everything that's happening on your screen, sort of, and like makes like a history of like everything you've ever done essentially on your computer.
It sounds extremely sketchy, but go on.
It's a little sketchy, but it's just, I mean, there can be some value to that. Like, oh, I had that one conversation when we were talking about that one thing, but I forgot what it was. And like, I could just ask this thing and it could like kind of tell me because based on like having seen like everything I've ever done on my computer, every text message I've ever sent, it can sort of like find information across different sources much more quickly. And so I think it's just like that's another example of like high resolution data. That's like a lot of content that you're interacting with, a lot of text that you're typing, and I think being able to like sift through that as like an assistant, and then surface that information for you, is maybe another application of this type of AI where it's not so much you're directly working with like a generative type of content. It's not generating anything new really, but it's just surfacing content for you, that might be difficult to find or that you don't even know exists. And so I think there's some cool applications there.
Last couple questions, then we'll call it. More broadly, what other applications of AI excite you in the future? What are you fired up about where this is all headed?
I mean, I think one that I think people have talked about this a bit, but on the generative AI side specifically, I'm just excited about the impact that it's going to have on like film and content and movies. I'm a big fan of just like cinema and like television, like good quality, shows and stuff. And I'm just really excited to see like how much easier it is going to be for people to like make these amazing movies and TV shows and just even just content you're seeing on like TikTok. I mean, it's going to go down to that level, but all that's going to be easier to generate like something that looks higher production quality wise without having the classical budget that we've had for like visual effects and everything. And I think that's really exciting that, it's just going to democratize like who can actually make content. And like, if you have an interesting idea for like a movie and you have an interesting idea for a script, like you can do it without like working in Hollywood. So I think like that's kind of cool that like that type of content's going to just get better, I think. And when you have more options in the market, like you should just surface better content in general. So I think like that's going to be really exciting. And then, that's going to extend to other things. I mean, for us, like as a startup, if we're trying to make ads right now, if we want to make like a high budget ad, it's very expensive to do that. If it's to make it look like really good and premium. I mean, I don't know, I'm not sure which ad you saw, but it probably wasn't like the best production quality. And like, we're on a startup budget, but if we had some tools that would make it a lot easier for us to do that, our content could get a lot better. The imagery on our website, could be like auto-generated through like some Photoshop AI tool. Like, I just think there's lots of good opportunities to just democratize that access to that really good content.
Last question for you. What advice do you have for other innovators or entrepreneurs out there who are playing with AI?
Yeah, I mean, I think one thing I would just say, at least from my experience, was we weren't trying to build an AI company. Like that wasn't really the goal for us. We were just really passionate about this market and this problem. And, one thing I didn't even mention, but like before we started SwingVision, we actually started out with a watch app, which was like manually tracking all the stats. So you would like manually track things on the watch, like keeping score and things like that. And then it wasn't until I worked at Tesla and like AI got better and the phones got more powerful that I realized like, actually we can automate this with AI. That just happened to be the solution. But, that would be my advice is like, find a market, find a problem that you're really interested in. But I think, don't be attached to the solution so much. I think like the solution might evolve and like whatever we think of AI today, it's going to change in like 5-10 years. But I think what's going to keep you like really focused and help you win is if you're just like really passionate about that market and that problem and you're willing to do whatever it takes to like solve that problem. And like if it happens to be AI, great. If it's not AI, then that's fine too. But like just solve that problem the best you can, provide the best experience to your customers. Like I think that's ultimately what people need to be focusing on, rather than like, oh, I got to do something in AI because like that's what's getting all the funding right now or whatever, right? Like that's not going to build a sustainable business, and you're just going to get replaced really quickly. And then I think the other thing I'll say too is like if you are going to go into AI, I think it's really valuable to build your own data sets, build your own training data, because that's how you'll get a defensible business. You won't be dependent on someone else's API, and you won't be giving them your data and like effectively helping their business get stronger and giving up your margins to some other company. Like I think, try to do as much as you can in-house and like build something novel, build a unique data set that's interesting. I just think you'll build a more defensible business. So if you're like thinking long-term, like I think that's the best way to build like an enduring company.
Awesome. Thanks so much for joining. Thank you for helping to improve my tennis game, which is a near impossible task. So I appreciate that. Best of luck to you and the app going forward. Can't just wait to see how you guys evolve. Thanks again.
Yeah. Thank you so much, Jeff. Appreciate it.
And thanks for listening to AI Curious. As a podcast host, I am now apparently legally required to ask you to share this and rate it 5 stars, write a review, send it to your loved ones, all that stuff. Thanks again, and we'll see you next time. Take care.